All righty, let's go ahead and get started for today. Today's lecture is fairly easy. It's basically an exam review. We have our first exam scheduled for Tuesday. And as I said in the last class, the way to, or what to expect from this test or how it will be run is going to be very similar, if not identical, to how the homework assignments are run. I will post onto Canvas Tuesday morning the test, a PDF file, the test. So you go to the module section, there's going to be a module called exams. And in that module will be the test. You download it. You work out all the solutions. You can either print out the test and work it out on the test paper itself, or you could just use a blank sheet of paper. Either way, you work out the questions. Number one, show all your work, obviously. And there's multiple reasons for this. First of all, as a professor, if I have a test paper from a student and all I see are the answers to each question, in this type of subject, physics and math and things like that, obviously require you to actually work out the answers. You can't just look at the problem and know what the answer will be. Inevitably, you actually have to do some work, whether it's plugging numbers into equations or doing some algebra or whatever the case is. So if I see just answers on a test, I have no idea how you would have gotten those answers. I mean, one can assume you did the work somewhere else, but if you already did the work, why are you not showing me the work? And so the natural assumption would be that, you copied the answers from somewhere else. So that's the first reason you want to show your work, just to prevent the professor from thinking you're cheating, because there's no way you could have gotten the answer without doing the work. And if you went through the trouble of doing the work, well, why not just show me the work? And secondly, the other big reason is because if there is something wrong with the answer, it's wrong or the decimal place is wrong or something like that, if all I see is the answer, then I have no choice but to mark the whole thing wrong. Whereas if you have your work, then I can see, how did you get this answer? And it might be that there was just a simple arithmetic mistake, or maybe there was a mistake plugging into your calculator, or there was a mistake, you didn't convert one of the units. Well, those are very minor mistakes. And so you would get most credit. I could give you partial credit for that type of thing. Versus, you didn't know how to do the problem at all. Well, that's a different story. And so I can't give partial credit if I don't see the work. I have to be able to see what you tried to do, and did it make sense? And was there just a simple mistake, or was this just something you didn't know how to do? So definitely you have to show your work. And then the other thing I ask is you box your answer. That's just for my own benefit. Everybody's different when they're working out tests. Some people are very, very organized, and it's very easy to see the steps they followed. Others, their work kind of goes all over the place on the page. And so it's not always easy to see what each step is and what the actual final answer is. Also, there are times where I'll have a student kind of doesn't know which way or how to solve the problem. And so they actually solve it two different ways and get two different answers. And then they give me the opportunity, if you will, to choose which of the answers I want to accept. Well, I mean, that's not right. You have to work out the problem and give me an answer. And so the best way for me, just to be able to see exactly what your answer is to box the answer. So a simple little thing. Once you get the answer, just put a box over it so I know, okay, that's the solution. And so I could follow your work a little bit easier. So anyway, you do all the work, you box your answers, you have the test finish. And then you just submit it back to Canvas, just like you do with all the homework assignments. You can either scan the papers in, you can take pictures with your phone, however you want to get it back onto Canvas, you scan it back in and submit it. And generally speaking, and specifically for this test, the deadline is due 11:59 p.m. that night. Okay, so you'll have the full day to work on this. I'm not going to set the test. You must do it during test time. And so once 10:45 in the morning reaches, you have to submit the test. None of that. You have the full day, and that just allows you the most freedom for how you want to work the test. Do you want to work it during the actual class time? Well, you have the opportunity. Download it in the morning, work it out. Since we won't be meeting for class on Tuesday, you could just work it while we would be having class and submit it. Or if you want to wait, maybe you're on campus and you want to wait till you get back home, that's perfectly fine too. You have the whole day to do it. And so there's very little excuse for not being able to turn it in on time. If you're traveling during the day or your work at some points, well, I give as much opportunity throughout the day to do it up till midnight that night. Now, just because the deadline's midnight doesn't mean you should actually wait till midnight to submit it, because I see it all the time. A student will email me at 2 a.m. or 3 a.m. or even the next day and say, oh, I tried to submit it, but something went wrong and now the deadline's over. Well, as a professor, again, that might be true. You might be honest, and there just was some technological issue that happened, and by the time it was resolved, the deadline had passed. Or it could be that you needed more time to work on the test and you didn't realize it was going to take you that long, or you wanted to wait for your friend to finish the test so you could see how they did the test, whatever the case, and now the deadline has passed and you're trying to give an excuse of why you didn't turn it in on time. Well, I have no idea which is the case. So another reason I give the full day to work on it is so that you have a long period of time. This is just going to be a normal test, as if this was an in-class test, an hour and 15-minute test. But I give the full day to work on it. That way you can try to submit it early. And if there is a technological issue that pops up, preventing you from being able to submit it on the website, or your internet went out or something like that, you can send me an email and say, look, this is going on. I just want you to know I have it. It's finished, but I couldn't submit it. What should I do? And then I could get with you personally to resolve the conflict. Whether I say, well, just email me the PDF, so I'll have it, and then you'll be able to submit it later or something like that. So that's my reasoning for giving the full day. You have as much freedom for when you want to actually take the test. It avoids any issues that would pop up, like I remember when I would do online tests as a student, and they were, you actually have to go there for a certain time. Once you're on the website, the timer starts and you have exactly 1 hour to finish and submit it. And if you don't do it within that 1 hour, then, you fail, or it's late or whatever. And then on top of that, if for whatever reason you're in there taking the test and something happens with the internet, or you get kicked off, or the window closes or something, well, it doesn't let you back on, because now it thinks you're trying to take the test again, kind of a thing. I want to avoid all that kind of nonsense. And so I give this way of doing the test. Plus, you're already comfortable with how assignments are turned in. So that relieves a little bit of the stress of having the test, in that you already know what to expect, you know how it's done. And so you don't have to worry about that. You can just concentrate on the test itself. What else about the test before we get into specifics of the topics? As I said, this is basically going to be exactly the same kind of test I would have given you in class. So if we were taking this test in class, this would be the test I'd give you anyway. It's an hour and 15-minute test, or it can be completed in an hour and 15 minutes. It's not like, well, since we're doing this online, I have the freedom of making it more complicated for you. No, I'm giving you the same test as if this were in class. And because of that, what I've found, generally speaking, for physics tests where everything is calculation questions, I don't do true, false, multiple choice nonsense. Physics is about actually working out problems. And so that's what the test questions are. I have found that somewhere between 5 and 7 questions is generally good for like an hour-long test. So 5 to 7 questions is what you can expect on these tests. Now that can change depending on the topic. Some topics can be done really quickly. And so maybe I can get more questions in since each question won't take as long. But I found, generally speaking, most people finish the test within an hour if there's between 5 and 7 questions. And so that's what this test will have, likely. Let's see, formula sheet. So any equations or anything like that, we have a formula sheet for the class. It's posted on Canvas, and I'll post it in the exam module section as well, so that when you download the test, it'll be right there for you to do or download. And it will have all the equations that would be necessary for the course. Okay, so this is something I do for when we have normal in-class lectures as well. I don't believe in forcing the students to memorize all the equations. I believe that, you know, if I'm trying to prepare you to be an engineer or a physicist or something like that, well, in real life, a person has access to the internet. They have access to textbooks or notebooks or things like that. They can look up formulas and equations if they happen to have forgotten them. We're not on a desert island where you have to build a tent and you have no outside resources, so everything is up to your own memory and how things work. So the formulas are given. It's just about, can you use the formulas to solve the actual problems? So you don't have to worry about that. And that brings to mind outside resources. What's available to you for you to use when taking the test? Everything. You're more than welcome to rewatch the videos while you're taking the test. You're more than welcome to go on YouTube or Google things or whatever, or look at the practice problems that are posted on Canvas. All of that stuff is there. And I'm not a fool. I'm not going to assume that you're going to be the highest moral person and honorable and not look at your old notes while you're trying to take the test. Of course you will. And that's perfectly fine, because what's more important to me is to make sure that you know how to work the problems. I give you a problem. Can you work the problem for me? And if you can, perfect. Now, the one thing I do say should not be at your disposal is talking with other people. So when you take this test, take it by yourself. Don't communicate with the other students. Don't get into a group to take the test. Don't have someone else work the problem for you. Do this yourself. This is your test. You work on it, because I want to see what your work is. I don't want to see whether you know how to get someone else to do the work for you. And it's easy for me to see when people cheat. And it's not just me, it's as a professor. It's surprisingly easy. When I graduated and started teaching, I didn't realize just how easy it is to see when people are cheating, whether it's in class and you're actually watching them take the test, or you just look at the tests themselves. It's quite clear when someone copies off of someone else. And it happens a lot. I see things like a particular weird math mistake has occurred as I'm grading through these tests. And so they get a wrong answer. And it's because, they accidentally put an extra zero in one of the numbers at some point, or something else, some weird thing that's rare to occur. And then all of a sudden, 4 other tests have that same weird mistake that would be rare to occur, but somehow now 5 people in one class did that same mistake. And at the end, they all have the exact same grade. It's like, okay, obviously there was some communication going on, whether it's full on cheating or you kind of got together and all worked the problem at the same time, whatever the case. All I ask is that you don't do it. Now, I'm not, I haven't signed it up for one of these kind of exam proctoring things online or anything like that. I'm not going to have you take these tests in front of a webcam. And so this is the honor system here. I have no idea if you will until I look at your test, and then I can tell. But while you're taking a test, I have no idea what you're doing. So I just ask, on the honor system, you have all the outside resources at your disposal. Just take this test yourself. Don't look at the work from someone else. Don't ask someone else for how they did something or anything like that. Just do it yourself. All right. So that is the formality of the test. Before I get into the topics, are there any questions on how the test will be run? All right, the only other thing I'll say is obviously you need a calculator because you need to get a final answer when doing this. I've seen every once in a while, I'll get a test where someone says they didn't have a calculator, and so they left all the numbers in the equation and didn't solve anything. That's not allowable. You actually have to solve and get an answer. And so you need access to a calculator. If you don't have a calculator right now, you need to make sure you'll have a calculator for test day, because you need to get an actual answer. And just to answer the question that comes up every once in a while about rounding and how many decimal places, since I don't follow the strict rules of like the significant figures and things like that, generally speaking, if you leave 2 decimal places, that's sufficient. You don't need to, have 18 decimal places or something weird like that. And also, if you use scientific notation when you have really big numbers, that's fine too. You don't have to use it, but you can either write out the number or you could use scientific notation. Both are fine. But when it comes to decimal places, usually 2 decimal places is more than sufficient to see whether you have the answer or not. All right, now topics. Well, as is true with all of the tests you will have in my classes, the topics that will be on the test are all the topics we've covered since the previous test. Now, given this is our first test of the class, that means all the topics we've covered since the beginning of the semester. Now, what I won't do is cover stuff from the math review section. So remember, at the beginning of the semester, we started with a math review. We went over algebra and trig and things like that. However, I'm not going to test specifically on that. So I'm not going to give you an algebra equation and say, solve this equation. Or I'm not going to give you a triangle and say, calculate this angle or whatever. All of that is tested through these actual physics problems. Okay, so where the test topics will actually begin is when we started into the actual physics, and that is when we started getting into electricity. So for electricity, which is what basically this whole test is on, we had a couple of different mini topics. The first was the Coulomb force. And this was the force that occurs between charged particles. So this type of question was something like you're given a charge at the origin and you have another charge over here. Let's say that's 5 meters away. This charge 1 is 1 times 10 to the minus 6 coulombs, and this is Q2 is -3 times 10 to the minus 6. And the question might be, what is the force felt by Q2 due to Q1? Okay. And what we saw was the equation for that was the Coulomb force is given by K Q1 Q2 over R squared. Okay, R is the distance between the charges. Q1 and Q2 are the values of the charges, and K was 9 times 10 to the 9, just a constant, a number. And we saw, plug the numbers in, get a force, and then you see, does that force make the object want to move to the left or to the right? And the way you figure that out is the rule that says if the charges are like charges, so if they're both positive or both negative, then they repel each other. So it'll get moved away from the other charge. And if they're unlike charges, so one's positive and one's negative, then they attract each other. So the charge will get moved towards the other charge. And so that allows you to say whether this force is positive or negative. If it moves to the right, it's positive. If it moves to the left, it's negative. Or if it moves up, it's positive. If it moves down, it's negative. Okay, so the equation won't give you whether it's positive or negative, but rather using your intuition to look at the situation. And when I look at this, if I'm asked the force on charge 2, I say, well, charge 2 is a negative charge. Charge 1 is positive. They're unlike, so they attract. That means charge 2 will be moved or pulled towards charge 1, which means he's going to move to the left. So this is a negative force. If, however, I'm asked what's the force on charge 1, well, again, they're unlike charges, so they'll attract. That means charge 1 is pulled towards charge 2, which is to the right. So the force on charge 1 is positive. Even though all the numbers are the same, which way the force is pulling the charge is what makes it positive or negative. And then we can also add in a third charge, some Q3, and say, okay, what's the total charge, or what's the total force on Q2 or Q1 or whatever. And we saw, okay, now we have to do this like a vector problem. You have multiple directions here, up and down and left and right. So you have X forces and Y forces. If I want to know the total force, then I have to find out what's the total force in the X direction and what's the total force in the Y direction. Once I have those two things, then I can do the magnitude of the total force as the square root of X squared plus Y squared. You know, this type of thing, magnitude of the force is the X component of the force squared plus the Y component of the force squared. And the direction is inverse tangent of the Y component over the X. Okay. So that was a little more complicated because we had to get X and Y components for each force. So let's say I want the total force on charge 1. Well, there's going to be two different forces acting on it, a force due to charge 2 and a force due to charge 3. So I look at the force due to charge 2 first. I forget about 3 as if he doesn't exist. I'm just looking at 1 and 2. And I say, okay, the force between 1 and 2, what's the X piece of this force? Blah, 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 blah. What's the Y piece of this force? Blah, 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 blah. Get numbers. Then I look at 1 and 3, and I forget about 2. So now there's just 1 and 3. What's the X piece of that force? What's the Y piece of that force? Now I have all of that stuff written down. Next, what's the total X piece? Well, it's the X piece of 1 and 2 plus the X piece of 1 and 3. Added together, you get a total X piece. And you do the same for the Y's. You get a total Y piece. Now I have total X, total Y. That's when I do magnitude and direction. Okay, so that means this is basically like two problems in one. You have the original Coulomb force issue where you're using equations to calculate the amount of force that's there, but it's also a vector problem. I'm trying to add two vectors together. So I need to get x and y components of the first vector, x and y components of the second vector, add the x's together, add the y's together, magnitude and direction. So it's a vector problem that uses equations to get the numbers. And so that's the Coulomb force topic. That's the equation, K Q1 Q2 over R squared. Of course, by Q1 and Q2, it could be Q1 and Q3, Q1 and Q4, whatever the actual charges we're talking about, but just to label it, it's the product of the charges over the square of the distance times this number, 9 times 10 to the 9. Now, the next topic, or the other topic we went over, was circuits. Basic circuit analysis. And here, the basic type of question we would have is, here's a circuit. It has some number of resistors in it. R1, R2, R3, R4, and some voltage source. And I'd like to calculate what's the total current running through this circuit and what's the total power. And so in order to do that, of course, we want to use Ohm's law, which says V equals IR. That allows us to get the total current. And P is I times V. That allows us to get the power. However, in order to use these equations, when we have a circuit that has multiple resistors, is we need to know what's the total resistance to put it into Ohm's law. So we need to figure out how to combine resistors. And we saw that there's two ways to combine them, depending on how they're connected. Either they're in series, in which case you'd say the total series resistance is R1 plus R2 plus R3, dot, dot, dot. However many resistors there are in series, you just add them up and you have a total series part. If they happen to be in parallel, then it's 1 over R parallel is 1 over R1 plus 1 over R2, dot, dot, dot. And so you would be given a circuit with all these resistors, and you one step at a time combine resistors together to simplify the circuit down until you're left with a single resistor, and thus you now know the total resistance of your circuit. Once you have the total resistance, you use Ohm's law to get the total current, and then you use the power equation to get the total power. Okay, so the key is all in, can you combine these resistors together? Do you know when resistors are in series or when they're in parallel? Or a combination? You know, I do the series first, then that allows me to do the parallel calculation. And once I've done that, I can do series again and so on. And that's it. That's the last topic. So really just two big topics. Given a bunch of charged particles in a system, you want to know what's the total force felt by one of them. That's a vector problem because you likely have multiple forces you have to add together. So you calculate the force due to each individual charge by itself. Each one of those has an X component and a Y component. Add the X's to get a total X, add the Y's to get a total Y, magnitude, direction. Circuits, you're given some complex circuit, multiple resistors. They're connected in some combination of series and parallel connections. Whittle them down. When they're in series, add them in series. When they're in parallel, add them in parallel, all the way down till you have a total resistance. Then you use Ohm's law to get the current, and you use power to get the power. All right, so that is it. Are there any questions on these two topics? Or on the test itself? All right, well, that's all I have. Definitely Practice. How would I study for this test if it were me? Obviously, there's a limited amount of time and you have other classes, you have homework in and stuff like that. If it were me, first of all, note that I create the tests and I also create the homework. So these are not departmental tests or anything that's made by someone else. I don't go, I don't have the fancy test bank by these corporations that make the textbook. I make up the questions. And I also make up the practice problems that are posted on Canvas and the homework problems that are there. So you already know how I ask questions. So the best way to study, the best way to get an idea of what the questions will look like on a test is to go back and look at the homework problems that have been assigned or the practice problems that are posted. The solutions are there as well. And of course, the example problems we've been doing in class. All the Zoom lectures are posted to Canvas, so you can just go back and watch them if you want. And the previous year's recorded lectures are there as well. So you go back and look at the particular videos where we worked examples. Well, those problems came from the same brain that's going to make your test. And so likely the test questions will look just like those. Different numbers, different setup, but the same vocabulary, the same way of asking the questions. So if you practice that stuff and you can do those problems, then there shouldn't be anything on this test you won't be able to do. I'm not going to put some questions on this test that are completely unlike anything we've done so far. I don't believe in that kind of thing. This is an introductory physics course. And so I'm trying to get you to work the problems at the most basic level to make sure you understand the fundamentals. Because if you're really good with the fundamentals, then when we do go to more and more advanced physics classes, they won't be as difficult. They just build on to what you've already done. So the test questions will be very similar to the practice problems or the homework or the example problems we've been working. So go back. Like I said, all the recorded Zoom lectures are there on Canvas. They just link you to YouTube and you just scroll through and look at the kind of problems we practiced in class. How do we work the problems and stuff like that? Those are what the test problems will look like. And so that's my suggestion. Work as many problems as you can just to get comfortable with how they sound, how they look, what is it I'm going to be looking for, when do I have to convert units, when do I not, all that kind of stuff. So other than that, as I said, it'll be posted in the morning on Tuesday. I'll send an email just to remind you. But you'll have the whole day to work on it and then send it in. Of course, my big suggestion is try to submit it early so that if there's an issue, we can resolve the issue before the deadline occurs. So I don't have in the back of my mind, is this person being legitimate or are they just trying to get away with the fact that they didn't finish it on time? And of course, as the test is being taken, if you have any questions on the test, you're more than welcome to ask me. Send me an email, and I'll be able to answer however I can. What I can't answer are questions like, here's my number 2. Can you look over it and tell me if I did anything wrong? No, I can't do that. I can't look at your answers and tell you if they're right or wrong so you can redo them. What I can do is answer questions like, look, I don't, in your Coulomb force problem number 3, I can't really see what the numbers are for charge 2. Is that a -3 microcoulomb or is it a -7? What is that number? Things like that. Or for number 4, are you asking me to find the total current or what is it you're asking? That kind of stuff I can answer. What I can't do is look over your test before you submit it. That's not possible. So definitely, if you have questions, definitely email, because the last thing I want is for you to be unsure about something and then you choose one way of solving it and it was the wrong way. If you're unsure of something about the test, email me. If I can answer it, I will. And if I can't, I'll tell you that too. But anyway, that's all I have. So if you have no questions, you're more than free to go and prepare for the test on Tuesday. I'll see you then.
Thank you.
All righty.